In this lesson, we will work through a procedure for graphing rational functions. First of all, let's determine the domain and any holes of the function f of x equals x over x squared minus x minus 2. I'll start by factoring. So I will have x over x minus 2 times x plus 1. As far as the domain goes, we want to make sure we don't have any zeros in the denominator. So for the domain, x cannot be equal to 2 and x cannot be equal to negative 1. That gives me a domain of negative infinity to negative 1, union negative 1 to 2, union 2 to infinity. There are no holes in this graph. As we can see, there are no factors common to the numerator and denominator, so I'll move on to the next thing we're looking for, which is x and y intercepts. To find x-intercepts, we would set y equal to 0. So for x-intercepts, I will have 0 equals x over x squared minus x minus 2. The only way that my fraction here is going to equal 0 is if the numerator is equal to 0, which would be x equal to 0, and I will have one x-intercept of 0, 0. For y-intercepts, I said x equal to 0. I will have y equals 0 over 0 squared minus 0 minus 2. That will result in y equals 0 over negative 2, or 0. And so I will also have one y-intercept of 0, 0. This happens to be the same as the x-intercept, so we have only one intercept for this function. Let's next find vertical asymptotes. F of x equals x over x squared minus x minus 2. Again, it's easiest to look at this with the denominator factored into x minus 2 times x plus 1. I'll set each of those factors equal to 0 to find the vertical asymptotes. And we have vertical asymptotes of x equals 2 and x equals negative 1. Okay, next, find the horizontal or slant asymptotes. Well, the degree of the numerator is 1, the degree of the denominator is 2, so we will have a horizontal asymptote, and the horizontal asymptote will be y equals 0. Next, let's determine the behavior between x-intercepts, vertical asymptotes, and holes. I'll draw a number line here that we'll use to create a sign chart. And let's start by, on this number line, let's put the x-intercept of 0, 0. So below the number line are my x values. Above the number line tells me what's going on with y. So when x is equal to 0 here, y will also be 0. Let's next look at vertical asymptotes. We have vertical asymptotes at x equals negative 1 and at x equals 2. What's happening at vertical asymptotes with y is that y does not exist, so I'm going to put a frowny face above each of these, the negative 1 and the 2 on the number line, to indicate vertical asymptotes at those 2 points. There are no holes in this graph, so we can ignore that. And next, f of x equals x over x minus 2 times x plus 1. I want to use that to determine what's going on with the behavior of my graph between the x-intercepts and vertical asymptotes. In the region to the left of x equals negative 1, I'll pick a test value, maybe of negative 2 here. If I plug negative 2 into my function f of x, I'll have negative over a negative times a negative. So my values in the region to the left of x equals negative 1 will all be negative. I'll pick a test value between negative 1 and 0, maybe negative 1/2, so I will have a negative 1/2 over a negative times a positive, which will give me positive values in this second interval on the sign chart. In the third interval, we can pick a test value of 1 over 1 minus 2 times 1 plus 1. We'd have a positive over a negative times a positive, which will tell us that there are negative values for y in this third interval. And in the fourth interval, maybe I'll pick 4 for an x value. I'd have 4 over 4 minus 2 times 4 plus 1. That will give us positive values in the last region there. Let's sketch a graph of this function using what we've learned so far. First of all, we have one intercept of 0, 0 here. I have a vertical asymptote at x equals -1. So I'll sketch the vertical asymptote. I have another vertical asymptote at x equals 2. So I'll sketch the vertical asymptote, x equals 2. I have a horizontal asymptote, which is the line y equals 0. And then we'll use our sign chart to help with the rest of this graph. So to the left of -1, my y values are below the x-axis. They're negative. And so I'll go ahead and sketch what's going on in this region. Notice that my graph is approaching the horizontal asymptote of y equals 0, and my graph is approaching the vertical asymptote of x equals -1. Between -1 and 0, my y values are positive, meaning my graph will be above the x-axis. Between 0 and 2, my y values are negative, meaning my graph will be below the x-axis. Again, we're approaching those vertical asymptotes. And to the right of 2, my y values will be above the x-axis, positive. And so we can finish off our graph like so, approaching the vertical and horizontal asymptotes. And this is the graph of the function. Try on your own to find the domain, x and y intercepts, vertical asymptotes, horizontal asymptote, and sketch a graph of the function f of x equals x minus 1 over 2x plus 3.